Hello everyone, welcome to the video lecture series of the subject Basic Electrical Engineering. Myself Pankil Sir, and you have seen so many videos of the subject Basic Electrical Engineering. And in this video lecture series, we will study the chapter AC circuits. So today's topic of this chapter is the analysis of AC circuit. So what do you mean by the analysis of AC circuit? Analysis of AC circuit means if we apply some voltage to any circuit, then what will be the instantaneous value of the current flowing through that circuit. We are applying voltage to any type of circuit, so we know the equation of the voltage or the value of the voltage. So what will be the value or the equation of the current flowing through that circuit that we need to analyze. So the concept is we need to find the magnitude and the phase angle of the current. So that means our current is having what magnitude, and our current is either in phase or our current is leading or it is lagging from the reference voltage. That is the part of this analysis. And also we need to draw the waveform of different type of circuit. Also we need to draw the vector diagram of different type of circuit. So here we will analyze the different type of circuits in this video lecture, that is the pure resistive circuit, pure inductive circuit and pure capacitive circuit. So first let's see the circuit analysis of the purely resistive circuit. So to analyze the performance of any circuit, or you can say to find the current through any circuit any AC circuit, we need to consider element connected in that circuit. In this diagram you can see that there is one resistor, and this resistor is supplied by an AC voltage source, and the value of that AC voltage source is given by Vt is equals to Vm sin omega t. This voltage is known as the reference voltage given to this circuit. So Vt is nothing but the instantaneous value of that applied AC voltage, and Vm is nothing but the maximum voltage applied to this circuit. So whenever we are applying this Vt is equals to Vm sin omega t voltage, AC voltage to this resistor, then there will be some current start flowing through this circuit, and we can define that current as It, and It is also nothing but the instantaneous value of the current. So now let's start deriving the equation of current through this circuit. So to derive the equation of current through this circuit, we need to apply KVL, or you can say Ohm's law. And we know that the Ohm's law, that is the relationship between voltage and current in any type of conductor. So whenever we are taking only resistor, if it is a purely resistive circuit, then the equation will be I is equals to V by R, because that is the Ohm's law. If our Ohm's law states that V is equals to IR, then I must be V upon R. So if we put the value of V in that equation, then it will be Vm sin omega t upon R. So that means our instantaneous value of the current It is equals to instantaneous voltage upon resistance, and the value of instantaneous voltage is nothing but Vm sin omega t upon R. If we take Vm upon R constant common from this equation, then equation will be It is equals to Vm upon R into sin omega t. And we know that Vm is the maximum voltage of this circuit and R is the resistance of this circuit. So that means Vm upon R is nothing but the maximum current flowing through this circuit. So the basic equation of current in this purely resistive circuit is I is equals to Im sin omega t. So what we obtain in this analysis of circuit is V is equals to Vm sin omega t was the voltage applied to this circuit, and we obtain the current's equation as I is equals to Im sin omega t. Look at carefully at both the equation. There is no phase difference between these two voltage and current quantities. So we can say that in purely resistive circuit, there is no phase difference between voltage and current. So now let's see the waveform of the voltage and current, how we can draw the waveform of voltage and current. So to draw the waveform of voltage and current, we must need to draw the x-axis and the y-axis. On x-axis, we will take the angle theta by which our coil is rotated. Okay. On y-axis, we will take our quantity, that is the voltage current. So how we will start drawing the waveform? So we will draw always reference quantity first. So here in our case, the reference quantity is nothing but the applied voltage V. So first we will draw the waveform of the instantaneous voltage Vt. So Vt is equals to Vm sin omega t. That means this is our reference quantity which will start from 0 and which will end at 2 pi. So you can see this waveform. In this waveform, our voltage is started from 0 and increased at 90 degree. Again it completed its positive full cycle at 180 degree and again it completed its negative full cycle at 360 degree. So this is nothing but we can say the waveform of a voltage, that is nothing but the sinusoid. So one must have a question, why this waveform is in sinusoidal form? Because you can carefully look our equation Vm sin omega t. That means our instantaneous voltage is function of sine. So the graph is of sinusoidal, and if we draw the graph of waveform of the current, then we know that the voltage and current is not having any type of phase angle. There is a zero phase difference. That means if our voltage is 0 at 0 angle, then current will be also 0 at 0 angle. If our voltage is reaching at maximum at 90 degree, then current will also reach the maximum value at 90 degree. But the magnitude of voltage and current is not same. Magnitude might be different, but at position at angle 90 degree, both will reach their maximum value. If our voltage was completing its full cycle at 180 degree, then current will also complete its full cycle at 180 degree. And if voltage was completing full cycle at 360 degree, then current will also complete its full cycle at 360 degree. So this is nothing but the waveform of the pure resistive circuit, waveform of the voltage and current in purely resistive circuit. Now, in any analysis of circuit, the phasor diagram is the most important term, and we need to draw the phasor diagram for any circuit, because from phasor diagram many things are clear. So let's draw the phasor diagram. So to draw the phasor diagram, let's take one reference axis. On this reference axis, you must have to first draw your reference quantity. And again, I am telling you that our reference quantity was the voltage. So we will draw the voltage across resistor on this x-axis. And if our current is making any angle with this reference axis, with this voltage, then you need to draw the current vector at that angle. But we have seen that there is no phase angle between the voltage and current, so the current will be on the same line as of the voltage. So here VR and IR, or you can say VT and IG, are in the same line, in the same phase. There is no phase difference between the voltage and current. So this is the vector diagram, or you can say the phasor diagram of the purely resistive circuit. Now lastly, we need to derive the equation of power consumption by pure resistor. So let's see the power consumption equation in purely resistive circuit. So to understand or to find the average power consumed by pure resistor over one complete cycle. So before finding the average power, first we need to find the instantaneous power. And instantaneous power is nothing but the power consumed by the resistor at any instant. Means, for example, if you want to find the power consumed by resistor at some 30 angle, or you want to find the power consumed by your resistor at 180 degree. So we need to first derive the equation of the instantaneous power. So to find the instantaneous power, the first equation to find the power is nothing but the multiplication of voltage and current. So P instantaneous is equals to V instantaneous into I instantaneous. Here we can say that Vt into It. So that means it is the multiplication of voltage and current. Now let's put the value of the voltage and current in this equation. So we know that the equation of voltage was Vm sin omega t and equation of current was Im sin omega t. So the equation of the instantaneous power is nothing but the P instantaneous is equals to Vm sin omega t into Im sin omega t. If we take Vm and Im outside from that equation, then it will be Vm Im into sin square omega. Now, after obtaining this instantaneous power, we need to integrate this instantaneous power to get the average power. But we know that the term sin square omega t is not directly be integrated. So for that, what we have to do is we have to put some mathematical formula for this sin square omega t. So the mathematical formula for this sin square omega t is nothing but 1 minus cos 2 omega t upon 2. So basically our equation of the instantaneous power is equals to Vm Im in bracket 1 minus cos 2 omega t upon 2. So this is the equation of the instantaneous power. Now let's find the average power consumed by the pure resistor over one complete cycle. So to find the average power, what we have to do is we have to integrate the instantaneous power within the range of 0 to 2 pi. So this will be 0 to 2 pi into P instantaneous with respect to theta, or you can say that with respect to omega t, and divided by 2 pi. Why we are putting divided by 2 pi? Because we are finding the average. So we must need to prove the base in denominator term. So the equation is in integration 0 to 2 pi Vm Im in bracket 1 minus cos 2 omega t upon 2 into d omega t upon 2. So if there are so many constant terms in this equation, so we have to take that constant outside of that integration. So the equation is Vm Im upon 2 and upon 2 pi. So basically it will be Vm Im upon 4 pi will be outside of that integration. So it will be Vm Im upon 4 pi in integration, it will be 0 to 2 pi, and in bracket it will be 1 minus cos 2 omega t d omega t. So now we have to integrate this term only, that is 1 minus cos 2 omega t into d omega t. So integration of that term will be omega t, or you can say theta. So the integration of 1 with respect to theta will be theta, minus integration of cos omega t will be sin omega t. So we have to prove the sin omega t, but here the term is cos 2 omega t, so the integration will be sin 2 omega t upon 2. So this is the integration of that bracket. That is the integration of 1 minus cos 2 omega t is theta, or you can say omega t minus sin 2 omega t upon 2, and bracket will be completed and limits will be 0 to 2 pi. First we need to put the upper limit and then we need to put the lower limit. So if we put upper limit in this equation, then it will be 2 pi minus sin 2 into 2 pi upon 2, that is 4 pi. And we know that sin 4 pi is 0, so that term will be cancelled, so only 2 pi will be there. Okay, this is the first one. Minus, now you have to put the lower limit, and lower limit is 0. So instead of theta, we will put 0, so it will be 0. And minus, there is sin 2 theta, so we need to put 0 in that equation, it will be sin 0 upon 2. And we know that 0 is 0 and sin 0 is also 0. So this whole term will be cancelled out and only 2 pi will be there in that integrated. Now please remember that what we have taken constant from this bracket is Vm Im upon 4 pi, and now what we have, that is 2 pi. So pi will be cancelled out. So finally we got the equation of the average power as P average is equals to Vm Im upon 2. So this is the equation of the average power consumed by pure resistor in one complete cycle, one full cycle 0 to 2. So now if we make 2 is equals to root 2 into root 2, and if we put this root 2 into root 2 in denominator of Vm and Im, then the equation will be Vm by root 2 into Im by root 2. Why we are doing this? Because often we know that our quantity will be in the RMS form, and here the equation is in maximum form. So Vm by root 2 is nothing but the Vrms, and Im by root 2 is nothing but the IRMS. And in general we can say that the average power consumed by pure resistor is nothing but the V into I, where V and I is the RMS values of the voltage and current. So in this way you can analyze any type of circuit, and in analyzing and while analyzing any circuit, you need to find the equation of current, magnitude equation, and the phase angle of current, means current is lagging, leading, or in phase, and also you need to draw the waveform and phasor diagram, and also you need to find the average power consumed by that circuit. So this was all about the pure resistive circuit. In next videos, we will analyze the pure inductor circuit and pure capacitor circuit. Thanks for watching this video. Stay tuned.